Let y as a function of x, fx equals x squared minus 3x. Okay, we have a function x squared minus 3x. Find the average rate of change of y with respect to x. Average rate of change of y with respect to x in the interval from x equals 2 to x equals 3. So one question here. From x equals 2 to 2.5 and 2 to 2.1. There are three parts for part A. So let's do that. And we know the average rate of change formula is given by f of second point fb minus fa first point divided by b minus a, where 2 to 3, that means a to, this is ab, 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 and we have to find 3 times. Okay, that is on the in the interval from x equals 2 to x equals 3. So f3 minus f2 divided by 3 minus 2, f3. So plug in x equals 3 here, x squared minus 3x, and use your calculator. Plug in 3 squared minus 3 times 3, 9 minus 9, 0. So this is 0 minus f2. Evaluate the function at 2. Plug in x equals 2 here. 2 squared 4 minus 3 times 2, 6. 4 minus 6, negative 2. Over 3 minus 2 is 1. 0 does not count. Negative, negative, positive 2. It's 2. So the average rate of change of y with respect to x in the interval from x equals 2 to 3 is 2. Let's do here. So let me write, this is over the interval 2 to 3. Next, over the interval 2 to 2.5, same formula. So f next point is 2.5 minus f2 over 2.5 minus 2. Now use your calculator and evaluate f of 2.5. Plug in the x equals 2.5 here. 2.5 is squared minus 3 times 2.5, and you're gonna get minus 1.25. Okay, using calculator. Minus f2, that's negative 2, over 2.5 minus 2, that's 0.5. So this is negative, 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 positive. So this is plus 2. Plus 2 minus 1.25. 2 minus 1.25, that's decimal 75 over 0.5. Okay, and use your calculator and get the value when you divide 0.75 by 0.5, and it comes out to be 1.5. Over the third interval 2 to 2.1, the average rate of change f of 2.1 minus f2 over 2.1 minus 2. Evaluate the function at 2.1. Plug in x equals 2.1 here. Okay, that gives negative 1.89 using calculator, minus f2, that was found negative 2, over 2.1 minus 2, just 0.1. Okay, this is negative, negative, positive. This is positive 2 minus 1.89. Use your calculator and subtract 1.89 from 2. Okay, just 0.11 over 0.1. Now divide this using calculator and we get 1.1. Okay, that's part A. In part B, we need to find the instantaneous rate of change of this function at x equals 2. So that's the pretty much derivative of this function using definition, and later we change x equals 2. Okay, and we know that the derivative or rate of change, instantaneous rate of change, is given by f prime x is by definition limit of f of x plus h minus fx over h as h goes to 0. Okay, that is, let me go down a little bit, and we want to find the average rate of change at x equals 2. So if we like, we can change x equals 2. Okay, at x equals 2, the average rate of change f prime 2 is given by this limit. F of x is now 2 plus h minus f at 2 over h. Let's evaluate this limit. This limit h goes to 0, h is a minus sign, and our function is given on the top, that is x squared minus 3x. Okay, x squared minus 3x. So the function, let me do over here, the function is x squared minus 3x. Now we need to find what is f of 2 plus h. So f of 2 plus h is equal to, simply replace x by 2 plus h. F of input x is equal to input square minus 3 times input. Now our input is 2 plus h, so f of 2 plus h is 2 plus h quantity squared minus 3 times 2 plus h. Now 2 plus h quantity square is not simply 2 squared plus h squared, that's wrong. We need to multiply 2 plus h by itself. 2 plus h times 2 plus h, this FOIL, then you get 4 plus 4h plus h squared. Okay, you multiply out these two binomials, minus distribute 3 times 2 6, minus 3 times h minus 3h is equal to, now let's simplify, so h is square, now we have plus 4h minus 3h, 4h minus 3h is 1h, and 4 minus 6 is negative 2. So f of 2 plus h, that's a lot of algebra, that's h squared plus h minus 2, and this minus from the formula here, f at 2, evaluate the function at 2, just plug in 2 here, 2 squared minus 3 times 2, that's 4 minus 6 negative 2, minus negative 2, minus negative 2, the same as plus 2. Now we take this limit, before that we just cancel this 2 and 2, and from these two terms on the top we can factor h out so that we can cancel h from the bottom. That's the limit, h goes to 0, h squared plus h out, that leaves h plus 1 over h. Now h cancel, plug in h equals 0, so h plus 1, that means 0 plus 1 is 1. So the instantaneous rate of change at x equals 2 is 1. Okay, let's go back. Now compare the results obtained in part A with the result of part B. Look at these average rates of change from 2 to 3. So basically we had this situation, here is 2, here is 3. In this interval 2 to 3, the average rate of change was 2. In the second part, 2 to 2.5, so 2.5 is here. If we come down towards 2, that means from 2 to 2.5, the average rate of change is 1.5. It's decreasing. And then we are even closer to 2.1. Now when we consider 2 to 2.1, then the average rate of change is 1.1. Now these numbers are decreasing towards what number? Towards 1. That's what we found here. If our next point is like say 2 to 2.00001, then that will be the average rate of change, which is same as the instantaneous rate of change. Okay, these numbers are marching towards 1. That's called limit value. So here's 1. Okay, so we don't have to do anything for part C. Yes, these values are, or you can say for part C, the values in part A are approaching to the instantaneous rate of change found in part B. The average rate of change, average rates of change are approaching to 1. That means approaching to the instantaneous rate of change at